Welcome to this ELIXIR Compute webinar. So this is an introduction to what the ELIXIR Compute Platform does as services. And we will also be presenting a demonstrator, what we have managed to do during the first year of our life as part of ELIXIR to the marine metagenomics. So the first slide, you see a lot of names, and so quite many people have contributed in order to get all the things in place. And this is not only the ELIXIR Compute Platform people, it is also the people from the marine metagenomics scientific services who are listed, because the work that we show in the demonstrator has required quite a lot of technical work from them as well. So the people presenting will be Alexander Agafonov, Inge Alexander Raknes, myself, Tommi Nyränen, Kimmo Mattila from next to me from ELIXIR Finland as well, and Dario Vianella from the EBI. So in short, the ELIXIR Compute Platform, the technical platform, is built for life sciences. So our purpose is to support bioinformatics with all the new technologies, tools, in order to make the data analysis services true, and to help the research, also the smaller emerging data resources, to create scalable services for science. Of course, we support also the core data resources in ELIXIR, but these big nodes, they usually have a different need for support. It all starts from an identity. So once a researcher or a service provider gets an ELIXIR identity, that provides means to get access to software, storage, and computational facilities coordinated by ELIXIR on the compute platform. So in order to compute on the data, you first have to get the data to the platform. So data movement is one essential part of the ELIXIR Compute Platform. So we are approaching the data transfer challenges from the viewpoint of the 4 scientific cases selected by ELIXIR, as well as the training use case. So the 4 scientific cases are marine metagenomics, plant genomics, human data, and rare diseases diagnosis. So these are the 4 scientific cases that drive ELIXIR forward as part of the EXCELERATE implementation grant. So these 4 cases have different needs for the data movement. So some of these cases, they need to transfer data from the big databases into the platform. Most of them have user-specific data that needs to be put into the same platform in order to put the user data into a bigger reference. And some of the data needs to be access controlled. If it's human data, you cannot just make it openly available for everybody. So some of the data will be available on the compute platform, adding value to, for instance, the cloud services, making computational access to data possible. This whole system will be sustained by the ELIXIR countries and the e-infrastructures. So it is clear that the compute platform that coordinates the different European nodes cannot provide all the different capacities needed by European biological research. But those countries, those ELIXIR nodes from the countries that have signed the ELIXIR consortium agreement, surely have fairly big resources to provide. These, combined with the e-infrastructures, will be able to provide the virtual servers and the storage capabilities to run the scientific software environments needed in biology. So ELIXIR Compute Platform sits in between the relying services, such as the marine metagenomics software data analysis pipeline, and the external service providers like e-infrastructures. So the ELIXIR Compute's service capabilities consists of what the nodes can deliver and what the European e-infrastructure can provide for biology for ELIXIR. It is not necessarily very easy to consume the resources that come from the e-infrastructures, and this is an additional role of the ELIXIR Compute Platform expert. It is to support the relying services to consume those resources, so helping people to get access to those resources. An example could be the identity federations provided by the Géant network. So I will go through shortly the three major services that the ELIXIR Compute Platform provides at the moment. So what we have done so far during the first year or so is that we have established an authentication and authorization service infrastructure. We have started working on the cloud and compute services coming from the nodes. We have also started the storage and file transfer services needed by the nodes and the biologists across Europe. So these services are delivered by the individual ELIXIR nodes in collaboration with their partners, such as the e-infrastructures in Europe. So today we'll demonstrate to you how these technical services have been set up to support the marine metagenomics scientific use case. So this will be two different angles to the report. So we have two different use cases, actually, two different scientific use cases. So one coming from the ELIXIR Norway and one from the EBI. So both are scientific services, but with a little bit different servicing angle when we reach the scientist level. So the technical facts have been documented into a public document, and the link is shown here. And there's also a contact address how you can reach the people on the compute platform. So this is the current status of the ELIXIR Compute Platform. Now, the authentication and authorization infrastructure services are needed for most of the compute platform services that we foresee. So, for instance, if you want a cloud server that is worth some money, so we need to know to whom that goes. So basically, you can create an ELIXIR identity for yourself today if you wish. So this identity is created by linking your existing electronic identities together to form the ELIXIR identity. So for instance, you can use your Google ID and your home organization ID and link them together. So this will form your ELIXIR ID. And this, in the long run, will be used to log in to services that need an access control. So this is beneficial also for the scientific service providers connected by ELIXIR. So the service providers, like the marine metagenomics, will benefit from a centralized user identities and access management services that can be coupled to the electronic federated identity. So it is also clear that the biologists need more and more servers to undertake the life science data analysis. So this is provided by the nodes already, so there are many cloud services coming from the ELIXIR nodes, and these are listed on the ELIXIR site. And we also are looking towards the external service providers in order to provide a uniform way to access those services. Some nodes, like our node in Finland, so we work with the biomedical human data, and there the security is an essential design criteria how the servers are catered to the institutes who have the legal right to process and analyze that sort of data. So in this case, specialized network solutions are needed, and these are something that the cloud and compute task of the compute platform provides as well. So storage and transfer services are important across the life science, and we have been looking at various ways of data transport. So to name 3 of them, so we have researched how the data replication and data submission takes place to ELIXIR data resources. The main resources, of course, the EMBL EBI and the key databases hosted at the EBI node. We also need services to pull relevant datasets, maybe not even the whole datasets from those data resources, and their replicas to cloud services, so that these big datasets can be computationally accessed and compared with the local data or local data analysis software setups. We've been also looking at that. Where are the key datasets at the moment located across the Europe, to discover any replicas that exist, and discourage if a replica already exists on a site that we would not download a second copy over there. If with their big datasets, this becomes a problem. So we want to discourage that. So this is all on the technical side, and one of the key roles of the experts working in the ELIXIR Compute Platform is trying to translate the scientific needs emerging from the scientific use cases, such as the marine metagenomics demo that we are going to see soon. So we need to translate the scientific needs to a language that the engineers can implement on the platform. So we have a concept called technical use cases, or TUCS, and we have identified 23 of these translations from science to technology that we are working on. Okay, so this final slide that I have is displaying how we have dissected the marine metagenomics service idea into these technical use cases. So if somebody asks that, can I use the marine metagenomics pipeline, the complex setup emerging from the ELIXIR Norway on a data? So what this means from the ELIXIR Compute perspective. So there are many different components that we need to set up to work together. But I'm not going to go into details of this. I'm instead going to give the floor to the Alexander and Inge Alexander in Norway to show how the ELIXIR Compute and their team has collaborated. Alexander, please. We can't hear you.
So if you can go to the next slide. Yes. So MetaPipe is a marine metagenomic pipeline that biologists can use to analyze marine metagenomic samples. It is built on top of Apache Spark, and we have a version running on it on cPauta. So if we can go to the next slide. This basically shows the web user interface as it looks like when an end user or a biologist visits the MetaPipe web page. If we go to the next slide. So this basically shows what happens when a user clicks on the menu to use MetaPipe. And you see that it's prompted with a question of whether or not you want to log into the AAI. And if the user clicks on this link, this big green button, we basically see this, where the end user can choose their identity provider.
So the ELIXIR Compute perspective here is that we provide the authentication and authorization services for the marine metagenomics portal maintainers. So basically, Alexander will know that who are the users, what their home institution is, and this is electronically confirmed, so they can be pretty sure that they know who their users are. As I told, social identities like Google can be also connected to ELIXIR ID. So this might not be enough trusted electronic identity. So it might be important for Alexander to to sort of request from ELIXIR AI a higher level of assurance that the people are who they claim to be. And this can be done by account linking. So if your Google account is linked with your home organization ID, that increases trust to that ID. So this is all done with a component ELIXIR ID proxy. So as you can see from this architecture build picture, so there are other functionalities in ELIXIR AI as well, like the group and role management and the access authorization management. Alexander, your turn.
Okay, in order for a user to run a MetaPipe job, the user needs to log in to our MetaPipe portal and upload the input data sets and choose the executor the user wants to run the job on and press on start. And on the next slide we will show how the MetaPipe portal looks like. So here basically when we press upload button, we upload the input files, and in the executor field, if you go to the next slide. Yeah, okay, so here we have uploaded a test file for the future job, and on the next slide we see that we want our job to run on Cipauta Finnish service. And finally we press start MetaPipe so that the job is being run on the execution environment.
So the execution of MetaPipe is basically this. It's a large range of tools that are running distributed on the Spark cluster within the CSC. Next slide.
So what exactly happens on the backend? The job is sent to the execution environment, which is running Spark, and the job is subdivided into multiple Spark tasks, which are executed on the worker nodes. On the next slides, we can see how it is represented on the yeah, this one. Bastion host, as we see on the picture, it acts as a gate that provides access to the cluster, and basically the Spark master, it fetches the information about the actually the Spark master is continuously listening, contacting the job manager that contains the job queue, and checks whether the job with the Cipauta tag is present. So now the executor gets the job we have currently submitted, and it downloads the files, and it runs the MetaPipe job on the slave nodes, which are disk 1 and disk 2 on this picture. And when the job is done, it uploads the resulting output files back to our storage server, and also updates the job status on the MetaPipe portal. Next slide.
Kimmo, would you like to add something from the service provider?
Well, from the service provider point of view, I'll go a few slides back, and as you could see, this is not an easy case to set up in for a local cluster cloud service provider. So you have to install plenty of tools, reference databases, take care of connections, and all that kind of thing, which sounds in the beginning quite kind of plenty of work. But the Marine Metagenomics group has developed this great cluster setup tool, so that actually now if you have a OpenStack cloud environment that is compatible with this environment, you can launch all these tools with just few commands. You need to edit few lines in a configuration file and run this tool that is provided by the Marine Metagenomics group, and in 1 hour you have the service running, which is, I think, quite significant, and allows then service providers easily to link to this service and then come out. So you don't have to keep the server all the time running. It's easy to set it up in a kind of a waiting mode, or completely set it up and shut it down if needed. So this is, in that sense, for the service provider, very flexibly and nicely produced tool, which allows you to set up a complex environment that is automatically even linked to the web interface in Norway, containing the authentication. Everything works just like that. And that, I think that's very kind of great feature in this tool. Let's go back then here and yeah. And then, yeah, you can continue.
Back to Norway.
Okay, so this basically shows how the end users will consume the data after it's come out of MetaPipe. So after MetaPipe is done running, the end user will download the result and it will open them in the basically in the programs that the end users are using. So if we go to the next slide, here you can basically see how the web interface looks like in the top here, where basically you have the download links where the user can download one of many outputs from MetaPipe. So currently available are, currently implemented are mgenbank and also FASTA files. Below here we can see an architectural drawing where we can see how everything fits together. Yeah, next.
Yeah, so just to add something from the ELIXIR Compute perspective here is that the scientists holding the soil sample or ocean sample here, they are not really maybe appreciating the delicacies of the infrastructure that they need in order to get all the data analysis pipeline done. So this is something that we have to somehow orchestrate in the ELIXIR, and it's especially important that since ELIXIR is a distributed infrastructure, that we understand each other in the value chain of the service production. So this concludes the first user story, and I would like to give the floor next to England, EBI. So the second user story.
Thank you.
Dario.
Hello, everybody. So the reason why we have chosen this marine metagenomics pipeline that is currently running inside our production cluster, the EBI, is that the amount of data the marine field is producing is kind of exploding. So of course they will need to offload part of the compute outside of what EBI offers, and this can obviously be solved pretty well both with public and private clouds. So if we just can go to the next slide. Okay, so what we were actually aiming to do was solving an initial need that was provide one-click deployments to several cloud infrastructures. And of course, it was very important to use industry standards that are widely adopted and possibly open source. And of course, easy to use is also a very good plus. And basically, the aim was not to reinvent the wheel once again. So the way we solved this is actually in the following slide. Was implementing what we call now the EBI Cloud Portal, which is a web application sitting on top of RESTful API that is able to serve both the main EBI Cloud Portal that we're going to see in a few seconds and the project-branded portal, so we can have the ELIXIR mainly portal. So this also supports, of course, programmatic clients, so you can code against the API. And the important thing here, and this is where ELIXIR is actually very, very useful, is the single sign-on. So you can log in into the portal using your ELIXIR account. And next slide, please. So this is basically how the thing works. So we got our Cloud Portal API and the web app, and that goes back querying for the ELIXIR AI to get the authentication bit, so we know who is logging in. Next. So the way we define application within the Cloud Portal is actually wrapping around Terraform and Ansible, that are two well-known and well-established tools out there. Terraform deals with the infrastructure provisioning, so actually spin up VMs, networks, and those kind of things. And Ansible that does the configuration, so setting IPs, these things. So what we did was actually building a common language for defining the application. And everything is stored into a Git repo, and it's the best way to actually collaborate and version the infrastructure, because of course Git allows you to version the software, the code, and then in this case you're actually versioning infrastructure. And of course, that also helps quite a lot in customizing every solution, because you can simply fork the Git repo and do your own customization, then pull everything back to the Cloud Portal. So first sneak peek of the Cloud Portal. Next slide. Thank you. So this is the console logged in with the ELIXIR AI. You get to this. Okay, these are actually two different screenshots. So the top one is our main welcome page. So you get to see your deployments. You can search the repositories for apps, and then manage data volumes. At the same time, we do also have a menu on the left to do the same thing. So going to Cloud Credentials. Next. Thank you. So here, ELIXIR is providing the authentication to the portal, but then you can use your own sets of credentials to reach out to cloud providers. In this case, I've got a set for our own internal OpenStack, and this is the EBI Embassy, and then a set for Amazon. Next. So what we did in the Cloud Portal was to completely separate the life cycle of storage and applications. And this is because you can reuse the same data multiple times in different deployments, so recompute on the same data. So this saves loads of time, actually. Next slide, thank you. And this is what the repository looks like. So just get a few cards, depending on which application you got. In this case, a GridFP server that you can use to transfer data in, or an OpenLava cluster to do your own compute. So this was, of course, enough to solve the first kind of need, so spin up infrastructure in the cloud. But then a second wave of needs and requirements came in. Next slide, thank you. And was actually not provisioning all the infrastructure, but provision entire pipelines. So this is kind of switching from infrastructure as a service to platform as a service. And of course, it will be very, very, very cool if pipeline sharing was fast, easy, and controllable. And to do that, we said, okay, let's reuse what we built within the EBI Cloud Portal as much as possible, because of course we don't like to reinvent the wheel too many times. And the idea we had, next, was to use images to share pipelines. So as you've seen before, we had an OpenLava cluster ready to go, and we said, okay, we can use images to hook, so pre-build the pipeline, save into an image, and then deploy the OpenLava cluster, attach on the fly a volume, and the content is given by this pre-baked image that's there waiting. And then use Ansible, that is the orchestration tool we use to do the orchestration to fire off the processing as part of the deployment. It's, in a sense, it's like plug and play pipelines. So if we can go to the next slide, thank you. Another click. There you go. So this is what the final result is. It's actually the same card we've seen before. As you see, the title has changed more or less. And at the moment, we are able to deploy this both to OpenStack and GCP. And flipping the card, or flipping to the next slide in this case. Next. Which is duplicated. Yeah, so next again, I guess. Okay, so you get to input the number of nodes you want in the metagen in the cluster, and then also the ENA ID. So what the pipeline is going to do as soon as we click the small violet button is actually deploying the cluster into the cloud, attach the volume with the pipeline, then the pipeline will go off, fetch the data from that study, and start the compute. So next, thank you. So this is just to show you that we click the button, the bar at the bottom should be actually going around, but of course this is a snapshot, so it doesn't work too much. But anyway, this is, as you can read in the card, it's actually starting to deploy. And if we go to the next slide, you can actually see a snapshot. This is actually the backend, so it's Ansible doing something. And you can see we are trying to locate where OpenLava is and then fire off the pipeline, which is actually the very last task. Next. And this is just a list of the nodes that has just been provisioned in the cloud. So you can see the 10 nodes, and there's already a job running in the, well, one of the nodes. Next. And this is all the jobs that has been run and are running in the cluster. So what the pipeline will do in the end is actually sending data back to some system managed by the marine team here on the EBI. So they will then use those results as a way to show more data, so get results more quickly to their own website that they're managing here at the EBI. So when the compute is done, next slide, thank you. We can simply destroy the cluster on the pipeline of the service if you want. So in this case, as you can see here, the state is destroying because the portal, in this case, just Terraform, is going off and actually saying to GCP in this case, okay, I'm done, my compute is done, feel free to kill everything because the data are already saved back at the EBI. Next slide, thank you. So what we learned is that deploying customized compute on demand is feasible. Of course, you need to pre-bake, so prepare your images as much as possible because that saves loads of time and a load of problems because you're dealing with an immutable infrastructure, so you know what is coming up. That doesn't depend on on-the-fly configuration. Put variables everywhere because flexibility in the cloud especially is everything, and you need to keep a sharp separation between infrastructure and workloads because in this case we would be able to simply swap the volume containing the marine pipeline with another pipeline and apply the same approach more or less. Next and last. So using images to share pipeline works quite well because it cuts the deployment time. So deploying the marine pipeline at the moment takes around 40 minutes. Pre-baking it in an image and just attaching it on the fly takes 5 seconds, so that makes it sort of a difference. And images are also very nice if you need to version, because you can have several versions of the same pipeline / image in the wild, and users can pick up the pipeline they want to use. There is no scaling issue because, again, you are referring to an image, so you can create as many volume as you want from out of that image. And the burden of coping with the scaling is moved back to the cloud providers. It's not something we need to bother anymore. And this last point is very true, especially for commercial provider where storage and volumes are not always equal in performance. So we can provide an image and then it's down to the user to understand what kind of performance they want out of the storage. They can actually pick a different price point or performance point depending on what they want to do. And this is mainly, this is more or less everything. So I think I can just give you back to you, Tommy.
All right, so we are close to the end of the presentation part of this webinar, but there will be a chance to ask questions afterwards. So I will just quickly summarize what we have said and conclude something from that and describe the next steps. So as you saw, the two demonstrators for the compute services we saw, they went on to a different level. So the first one was more about collaboration between the experts in two nodes, whereas the second one, the EBI, went really deep into the technical details. So we are happy to discuss either aspects, but next, the conclusions. So the marine metagenomics will not be the only demonstrator that we will tackle in the compute platform, as I said. So we'll have 4 scientific use cases and training coming up. The next priority during 2017 is human access control data support. So we will work with the major archives in ELIXIR, like the European Genome Archive, and to try to create a way to send the data for analysis on secure or approved cloud platforms with the support of the ELIXIR Compute Platform. So this is work done elsewhere in ELIXIR as well, but we expect that local service providers will be needing components like electronic identity and data transfer as well. But our main focus will be on the human data transport next year, so that we can actually work with distributed clouds to provide enough security for these data resources to trust the system. So this will be the next year's similar demonstrator around the same time of the year. To conclude something where we are, based on the experience that we have now had with the marine metagenomics from the technical angle. So I think we can conclude that automated and scalable setups made by the ELIXIR nodes who have cloud resources or compute resources available for them are technologically suitable for the bioinformatics software stacks and data for marine metagenomics. So like Kimmo said during the presentation, that in the Finnish cloud it only requires few commands and less than 15 minutes to deploy a cluster that is suitable for the analysis, and then 45 minutes for the software stack and data to be uploaded there. And a similar level of automation, maybe a little bit differently organized using a little bit different components, is made possible by the EBI technical services team. We also see that the encapsulation of the scientific software pipelines built by the bioinformatics experts in containers is a useful and encourageable activity because it increases the portability of the software expertise. And when the software is in containers or images, it will provide the extensibility to the ELIXIR's distributed infrastructure. The challenge that remains, that is unresolved, is how do we streamline access to cloud resources to identified users and service providers. So this is something that cannot be solved at the ELIXIR Compute Platform level. This is a European challenge, but I'm confident that Europe will solve this in order to support the biological information and research. So with this, I would like to conclude the presentation.